Balancing chemical equation. The law of conservation of matter states that in a closed system, matter is neither created nor destroyed, just transformed. So, for a balanced chemical equation, we are saying that the reactant side must equal to the product side. So let's use an example. I have hydrogen plus oxygen forming water. Now, right at the bat, I can see that I have two hydrogen and I have two hydrogen over there, so that's balanced. But I have two oxygen over here, but I only have one oxygen over there, so that isn't balanced. So in order to do this, I'm going to have to write a 2 in front of this water, so that I will now have two oxygen over here and two oxygen over here. Now, I have four hydrogen over here, but only have two hydrogen over there. So to balance that, I have to write a 2 in front. So now I have four hydrogen and four hydrogen, two oxygen and two oxygen. So this is now a balanced equation. Let's take a look at this example. In the first equation, I have one copper, two hydrogen, and I'm going to keep the SO4 as 1 unit, so that's 1 SO4. On the product side, I have one copper, two hydrogen, and 1 SO4. These are all balanced, so this is a balanced equation. Let's look at the second example. I have 2 aluminum, 3 oxygen, 1 carbon, and 1 oxygen. Over here, I have 2 aluminum, 1 carbon, and 2 oxygen. I'm missing 2 oxygen. So this is not balanced. Let's take a look at this example. I have 1 iron over here. 2 chlorine, but 4 chlorine over here. That's not balanced. Let's look at this example. I have 1 potassium, but 2 potassium over here. That automatically make it not balanced. Let's look at the next example. I have 2 Ag, which is silver, and I have 2 Ag over here. That's balanced. Let's do Mg first. I have 1 Mg over here and 1 Mg over here. I have 2 units of NO3, so that's 2. And over here, I have 2 units of NO3, so that's 2. So this is a balanced equation. Now let's look at this example. I have 1 Mg, so 1 Mg over here. I have 2H over here. And I have 2Cl and 2Cl over here. So therefore, this is also balanced. So again, let's remind us. The law of conservation of matter states that the number of atoms should be balanced on both sides of the arrow. In other words, the number of atoms on the reactant side must equal to the number of atoms on the product side. Now, when you balance the chemical equation, there's certain things you cannot do. One, you cannot change the subscript, because if you change the subscript, you change the compound. And two, you cannot place a coefficient in the middle of a formula. So let's take a look at this example. Again, this is the H2O2 water example. I have H2, I have O2, and I have water. Note I have 2 H2 over here, I have 2 O2 over here, I have 2 H2 over here, and 1 O over here. So using the T structure, I can actually identify H is equal to 2 and O is equal to 2. And I want to keep it equal, so whatever elements over here must equal to here. So H and O. And I have 2 here and I have 1 here. So the hydrogen are balanced, but the oxygen are not. So if I have 2 oxygen over here and 1 over here, I need to make this a 2. And when I make this a 2, this automatically get moved up to here. So this is a 2. And when I did that, I now have 2 oxygen, but I now have 4. 2 times 2 is 4. I now have 4 hydrogen. So I need to change this to a 4. And when I change this to a 4, I have to balance it over here to make this a 4. And now I got to make this a 4 up here. We already have 2 hydrogen. So in order to make this a 4, I just write a 2 right here. And so now I have 4 hydrogen, 2 oxygen, 2 oxygen. And so in this case, I will leave this blank. Or if you want, you can put a 1. But majority of the time, you leave that blank. So let's take a look at this example. I'm going to use the T structure. And I'm going to identify my element. So I have H, Cl, and Cu. I have one H, one Cl, and one Cu. Over here, remember whatever element is on one side must be on the other side. So I have 2H, 2Cl, and 1 Cu. So let's balance it out. So I will always leave hydrogen and oxygen to the end. So my Cu are already balanced. And I just now need to balance the Cl. So I have 2 over here. I'm going to need to change this to a 2. When I change this Cl to a 2, since whatever I do up here, I got to move it up to this location. So I'm going to write a 2 right there. Now, what did that do to my H? It made my H a 2 now. So I'm going to have to change that to a 2. And when I change that to a 2, guess what? It is now balanced with my H over here. So therefore, my equation is now balanced. Let's take a look at this equation. In this equation, I have Na and Cl. Over here, I will also have Na and Cl. I have 1 Na and 2 Cl. Over here, I have 1 Na and 1 Cl. So I know I need to balance the Cl. I have 2 Cl over here. So I need to have 2 Cl over here also. So I'm going to change that to a 2. So when I change that to a 2, I got to move that 2 up here. So that one now becomes a 2. When I do that, my Na get changed to a 2. And since I have 2 over here, I must make a 2 over here. So therefore, I'm going to make that a 2. And so I need to bring it up. And now I have 2 Na, which balance itself, and 2 Cl, which balance itself. Let's take a look at this example. In this example, I have Na equal to 1, oxygen equal to 2. Remember, the same element must exist on both sides. In here, I have 2 Na and 1 oxygen. So let's balance the Na first because we are going to leave the oxygen till the end. So there is 2 Na over here, so there needs to be 2 Na over here. So I'm going to change that to a 2, bring my 2 up here. Okay. Now I have 2 oxygen over here and 1 over here. So I'm going to change this oxygen to a 2. And when I do that, I will then bring the 2 upward. And now I make this a 2. But by making this a 2, I now change my sodium to become a 4 because it is 2 times 2 is 4. So now I'm going to change my sodium to become a 4. And over here, I got to do the same thing. I'm going to change that to a 4. If I change this to a 4, I now must change this to a 4. And now my equation is balanced.